In this video, we learn how to code a D flip-flop using sequential coding. So let's get started. So I have created a file called dff.phd, which stands for dflipflop.phd. I have created an entity called dflipflop, and I have created this interface for the entity. So CLK stands for the clock signal. So we'll be pumping a clock into the D flip-flop. D is the input signal. RSA is the reset signal. Q and Q bar are the outputs. So D is the input signal, which will be which the D flip flop will store, and RST is reset, which stands for So if reset will be one, the outputs will be zero, and output will be zero, and Q bar will be one. Q bar will be one. So how does a D flip flop function? So whenever the clock will go from 0 to 1, so the clock going from 0 to 1 is called a rising edge, because it's a rising edge, right? Going from 0 to 1. Our D flip flop will read from D and update the output. Otherwise, it retains its last state. So so let's get started. So we would want to define its architecture. So let's call its uh, behavior. Architecture behavior of D flip flop is, and let's just begin architecture and end architecture first. The next thing is we'd want to write it sequentially. So you need to first define a process, and we would write its sensitivity list. So we would want this process to trigger every time there's a change in the clock, because we want to detect a change in the clock going from 0 to 1, right? So the process should run every time there's a change in the clock. So process clock, clock is in its sensitivity list. We just begin and end process, and so we want a method to check where the clock is going from 0 to 1. So there's a built-in function called rising edge. So if rising edge of clock, then if rising edge of clock, then we first check if the reset bit is 1. So if the reset bit is 1, then Q should be set to 0, and Q bar should be set to 1, right? Else, if the reset bit is not 1, then we should propagate our input to the output, right? And Q bar should be not of D. And that's it. So just to recap, rising edge checks if the signal is going from say 0 to 1, and so we first check if we are on a rising edge of the clock. If we are on the rising edge of the clock, we first check the reset bit. Else, we just propagate the input to the output. That's it. That's how we code a D flip flop. And now let's code a test bench for a D flip flop. So I'll call it dfftv.vhd. Let's copy a test bench from the NAND gate, and let's change the component part over here. D flip flop, and let's copy the port mapping from here. And let's change this instance as well. So regarding the signals, we need 5 signals in this case. So signal, say C, CLK, D, RST, Q, and Q bar, all of which are SCD logic, right? Let's map those to the inputs of the D flip flop. So remember, the left hand side of the arrow stands for a pin of the D flip flop, whereas the right hand side stands for our signal over here, this signal, these signals. So we would want to map clock of the D flip flop to our signal clock, D of the D flip flop to R signal D, RST to RST, Q to Q, and Q bar to Q bar. That's all. And let's vary our inputs and outputs. So say initially I set D to 1. And now remember that we have to pump clock ticks into our D flip flop, else it won't work. So say initially the clock is 0, and let's wait for 1 nanosecond over here. And then say the clock becomes 1. And let's wait for another nanosecond. So this is a rising edge of the clock from 0 to 1. And we hope that D will be the output will be updated to 1, because on the rising edge it is supposed to propagate the input. So yeah, let's feed some other ticks as well, some more ticks as well. Uh, so so here's a rising edge. This is a rising edge, and this is a falling edge. This is another rising edge, and this is a falling edge. So, and this is another rising edge over here. So what happens if I update the input again over here after a rising edge and provide it with ticks, more ticks? So hopefully, what we hope is that this D will be updated after, yeah, so after this rising edge over here. Hopefully, it won't get updated. Yeah, in this falling edge. That's how the D flip flop is supposed to work. So that's it. So let's start simulation. Let's open model sim. Let's create a new project. Let's change the directory. Uh, okay, my bad. Uh, yeah, let's change the directory over here. And let's add files. Add the files that we have. VHDL and DFF and DFFTB. That's fine. Let's add them. Nothing more to add. And let's compile them. Hopefully they compile with no errors. So there are 5 errors. Let's just check them quickly by double clicking on them. So if there's some semicolon missing, so 27, 31, like these lines on over here. So, oh yeah, I forgot the for statement. So wait for over here as well. Wait for, and wait for. And let's compile it again. Let's close this and compile this quickly again. So now there are no errors, and let's start our simulation. So let's go over here, open our test bench, and click on simulate. Let's add signals for clock, our input, our Q bar, Q and Q bar, and let's change the simulation length to say 20 nanoseconds, and let's just run the simulation. Uh, so we don't want this signal. Anyways, like it's fine, but like yeah. So for now, like let's look at the clock, D and Q bar signals. Um, see we have. Let's just delete this signal. RST and okay, this is so not needed. Yeah. So let's look at this. So this is the first tick of the clock. So D is set to 1, however the clock hasn't started to tick. Like the clock is still 0. So the output is still undefined because we didn't set a default value for the output. So once the clock goes transitions from 0 to 1 over here, you can see that the output gets updated to 1 0, right? And the next thing is the output retains its value across these clock ticks. It doesn't change. The output doesn't change. So let's get to the part where the input is changing over here. So we change the input to go from 1 to 0. So clearly over here, the clock is transitioning from 1 to 0 and the input is also going to 0. But the output is still 1. It is retaining its previous state because it will update the output only on the rising edge of the clock. So on the rising edge of this clock over here, the output is now becoming 0 because yeah, so we updated the input to 0 and on the next rising edge the output is becoming 0. So yeah, it seems like our flip-flop is working correctly, and yeah, so that's pretty much how you code your D flip-flop using sequential coding. Thank you.